Okay, so there was one more quick topic with ellipses that I did want to try to get through, and it is called the eccentricity. Okay, this is eccentricity. I don't know why it's not, there it goes, eccentricity. Now, there are 4 examples here, and you can see what the eccentricity is of each ellipse. So the first ellipse, the eccentricity is 0. Looks like a circle. It is a circle. The second eccentricity is 0.75. The next eccentricity is 0.94. And the last eccentricity of this ellipse is 0.99. So if I told you that the eccentricity of an ellipse, I forgot to put this up here, but we'll go over what the formula is here in just a minute. But if I told you that the eccentricity of an ellipse, E, I guess they're calling it big capital E, if I tell you that the eccentricity of an ellipse, E, is always a number between 0 and 1. Never equal to 0, never equal to 1, because if it's equal to 0, then look at what happens. When the eccentricity equals 0, then we end up with a circle, okay? So the closer the eccentricity is to 0, the more circular the ellipse is. The more circular the ellipse is, okay? The closer the eccentricity is to 1, look at this, like 0.99. Look at what kind of graph we have here. We have an ellipse. It's really skinny. It's very elliptical. We'll call that elliptical. It's more oval-like, the more elliptical the ellipse is. If E equals 0, then we do have a circle. If E equaled 1, then we would just have a line. It wouldn't even be an ellipse anymore. It would just be a line. That's all it would be. Okay, now what is the formula? How do we find the eccentricity? The eccentricity is the ratio of C over A. We just take the C value and divide it by A. C divided by A. Okay, so in these last examples here, find the eccentricity of each ellipse. So we know that the eccentricity is C divided by A. Okay, well, what is C? Well, we need to kind of figure that out. We don't know what C is yet, but we do know what A is, and we do know what B is. So let's see. A is going to be 5. And B is going to be 4. And I know that C squared equals A squared minus B squared. So C squared is 25 minus 16. 25 minus 16 is 9. C is 3. So the eccentricity is C over A, or 3 over 5. Okay, if I look over here, we know that A is equal to 1, 2, 3, 4. A is equal to 4. B is equal to 1. C squared is equal to A squared minus B squared. So 16 minus 1, C squared. C squared is equal to 15, so C is equal to the square root of 15. E is equal to C over A, square root of 15 over 4. There you go. We can come up with a decimal here, square root of 15. I guess I could have done that with a 3/5. I just usually leave things as fractions, but square root of 15 divided by 4 is about 0.968. So really close to 1, and we can see it's definitely more elliptical. Here, 3/5 is 0.6. 0.6 is not as close to 1 as 0.968, so it's a little bit more circular. Still looks elliptical, but a little bit fatter. Okay, so that concludes this lesson. That helps us with that eccentricity.